Hey guys, welcome to our advanced activity. So in this unit, you have been exploring how different environmental factors have affected plant growth. And you've also been practicing CERs. Now, if you find yourself doing this activity, it means that your teacher has seen you master some key skills that make them believe that you can tackle on something a little bit more challenging. And so you have been assigned this CO2 photosynthesis challenge. We're going to start off with a review of photosynthesis and just looking over some experimental data and doing a practice CER with it again. And we're going to end up with a new set of data, and you're going to complete a CER all on your own using the first example as a model. So without further ado, let's get started. So the equation, or actually the model picture you see on the right, is for photosynthesis. And one of the products of photosynthesis is oxygen. When there is a high rate of photosynthesis, there is a lot of oxygen being produced. The opposite is also true. Low oxygen levels indicate a low photosynthesis rate. Robert wants to explore how carbon dioxide concentrations affect the rate of photosynthesis. So he varies the amount of CO2 a plant receives and measures the amount of oxygen that is produced. So if we take a look at this visual here, you see some arrows going into the chloroplast, right? The site of photosynthesis in plants. You see some sunlight, you need carbon dioxide, and you need water. And those are the reactants. Now, for our products, the process of photosynthesis gives us oxygen and sugar, which we call glucose. Now, the amount of CO2 that a plant received was varied, okay? And the amount of oxygen was recorded. And so this is the data that we collected below. When the CO2 levels were 130, the O2 flow was 15.3. When the CO2 levels were 160, the O2 flow was 30.3. And when the CO2 levels were 270, the O2 flow was 40.2. So now that we have that data, let's go and tackle a CER. So for each component of the CER, I have included a guiding question that's meant to help you with that part of the CER. For claim, the guiding question is, what happens to the O2 concentration when the CO2 concentration is increased? For evidence, what data from Robert's experiment supports this? And for reasoning, the guiding question is, how does an increase in CO2 levels affect photosynthesis and O2 concentrations? So go ahead and tackle this CER on your own. And when you're done, press play so we can review it together. So welcome back, guys. We're going to quickly review this, and then you're going to tackle on a second CER on your own. So for our claim, we're going to state that when we increased the CO2 concentrations, the O2 concentrations increased as well. Now, in the evidence component, or the evidence part, we're going to go back to our tables, okay? And we're going to use specific data. So when we went from 130 ppms of CO2 to 160, the O2 flow increased from 15.3 to 30.3. And we saw another increase when we increased the CO2 levels from 160 to 270. The O2 flow increased as well from 30.3 to 40.2. So our evidence is right here, right? We can say that when we went from 130 all the way to 270 ppms of CO2, the O2 flow increased from 15.3 to 40.2. Now, what is our reasoning, right? How does an increase in CO2 affect photosynthesis and O2 concentrations? And for that, we can refer back to the reading, right? Where it states in the first paragraph that when there is a high rate of photosynthesis, there's a lot of oxygen being produced. The opposite is also true. Low oxygen levels indicate a low rate of photosynthesis. So what we're seeing here is that as we're increasing the amount of carbon dioxide, which is one of the reactants, we're also increasing the rate of photosynthesis and therefore producing more oxygen. Now, it is important to note that the rate of photosynthesis will increase until it's limited by another factor. But for the sake of this activity, at this point, it is not. All right, guys, so now you're going to be exploring the role of the light intensity and photosynthesis, which goes back to our experiment with plants, right? Because one of the things that we changed was sunlight exposure or light intensity. So Robert wants to explore how light intensity affects the rate of photosynthesis. He varies the amount of light intensity a plant receives and measures the amount of oxygen that is produced, of course. So you want to review your data carefully, and I always encourage my students to annotate the chart. Now, once you're done annotating and analyzing the data, you're ready to tackle on the CER. I've included some guiding questions to help you, but if you want to do this independently without the guiding questions, you're more than welcome to type this on a separate piece of paper. It really is up to you, whatever works best for you. So good luck with your CER. I can't wait for you to impress your teachers with your knowledge and your expertise. And I will see you next time for a review on a different topic. Bye, guys.